Factoring trinomial is when the coefficient of the quadratic term is not a 1. So, first example we'll do is, say we're given 8y squared minus 10y minus 3. Now once again we're going to be doing what's called the rainbow method, or AC. So we're going to take our a times our c term, so 8 times negative 3 gives us negative 24. So I want factors of negative 24 that add to equal my b term of negative 10. Well, factors could be things like 6 and 4. One of them has to be positive, one has to be negative, but that won't give us negative 10. And the reason one has to be positive and one has to be negative is because when you times, you have to have that combo to get a negative out of a multiplication. Well, what if I did negative 12 and positive 2? Well, that would times to equal negative 24 and add to equal negative 10. So I'm going to stick those in for negative 10. So I get negative 12y plus 2y minus 3. Group in pairs of 2, since we had 4 terms, pull out what's common, and the first thing what's common is a 4y, leaving me with 2y minus 3. There's nothing common in the second term, so I'm just going to plot a 1. So since they share this the same, 2y minus 3 becomes the first term. What you pulled out becomes the second. And this would factor to become 2y minus 3, 4y plus 1. You can check yourself by foiling this. You should get back to here. (10r squared) plus 19r plus 6. AC, 6 times 10 equals 60. Factors of 60 are 6 and 10. Well, that doesn't work. It gives us 16, not 19. 2 and 30 doesn't give us 19 at all. 4 and 15, that would work. So we're going to say 10r squared plus 4r plus 15r plus 6. Group in pairs of 2. What's common between 10r squared and 4r is a 2r, leaving me with 5r plus 2. Out of the second pair, I can pull out a 3, leaving me with 5r plus 2. So the 5r plus 2 becomes one term, and 2r plus 3 becomes our other. And we have factored 10r squared plus 19r plus 6. Trying another example. So let's say, for example, that I have 12a squared minus 19ab minus 21b squared. Well, 12 times 21 gives us 252 negative. So factors of 252 negative that add to equal 19. Well, negative 28 and positive 9 is one option. So I have 12a squared minus 28ab plus 9ab minus 21b squared. Group in pairs of 2. What's common out of the first? Well, I can pull out a 4 and an a, so I'm left with 3a minus 7b. Out of the second pair, I can pull out a 3 and a b, so I'm left with 3a minus 7b. These match, that's good, that's what we want, or else we've probably done something wrong and we need to go back through the problem and relook at things. They become one term. What you pulled out becomes the other term. And we have factored it. Now, all of these examples we're doing have the exact same process, and I'm just doing many of them, so you can, if you need help, you can keep watching to get more ideas on how to go about these problems. So something you sometimes need to look for is, or you always need to look for, but a lot of problems don't have it, is what's the greatest common factor you can pull out at the beginning. Notice how these all share a y in common, so I can pull out a y to begin with. And I would say 12 times 9 is negative 108. So I want factors of 108 that add to equal 33. Well, what are some options? 254, 3 and 36. You could keep going. 4 and something. 6 might. Keep trying out different pairs. But if I want a negative 108, I have to have a positive and one negative. But if I want a positive 33, when I add, that means the bigger number needs to be positive. So I'm going to make the 3 the negative number. So when they multiply together, become negative 108. Add together, they'll become positive 33. The y stays on out front. It just tacks on for the ride. Minus 3y plus 36y minus 9. Y stays out front. What I can pull out common out of this first pair is a 3y, leaving me with 4y minus 1, plus pulling out a 9, I'm left with 4y minus 1. So the y stays out front. 4y minus 1 is common, and what I pulled out of them is 3y plus 9. So the factorization will have the greatest common factor just out front. He just tacks on for the ride. If you notice, without it, it's just a normal factoring of this quadratic. Let's do another set of examples. Say we're given 3a plus 2 squared minus 11a plus 2 minus 4. So one thing you could do at the beginning, if this is overwhelming to see these in parentheses, is say x is equal to a plus 2. And then we make a substitution. So we say 3x squared minus 11x minus 4. And it's something we're more familiar with. So then what we do is say, okay, I want factors of negative 12 to add to equal negative 11. Well, that's negative 12 and positive 1. So I have 3x squared minus 12x plus x minus 4. Group in pairs So pulling out the common of 3x, I get x minus 4. There's nothing common in the second set, but that's okay because it actually leaves us with the exact same thing inside of the parentheses. So we pull out that x minus 4, leaving us with 3x plus 1. The last step of this, we made a substitution at the beginning, so we have to undo that. So instead of x's here, I write a plus 2. So I get a plus 2 minus 4, 3 times a plus 2 plus 1. Combining like terms, I get a minus 2, 3a plus 6 plus 1. So the front one stays the same. The second one combines to be 7 instead of 6 plus 1. So factoring this could look like this. One last example. This one can also be done with substitution. Say we're given 6x to the 4th plus 11x squared plus 3. So notice I don't have an x squared and x here, but it's not a common term that I can factor out front. So one thing you can do is say y is equal to x squared. Okay, so here's that substitution. So instead of x to the 4th, I would say 6y squared plus 11y plus 3. Because this is the same thing as saying, so x to the 4th is the same thing as saying x squared squared. So instead of x squared, I write a y, and it becomes y squared. Instead of x squared, I write a y. So this is the format we're used to. So we'd say factors of 18, because 6 times 3, that adds equal 11. Well, that would be 9 and 2. So we'd say 6y squared plus 9y plus 2y plus 3. Group in pairs of 2. Pulling out a 3y, I get 2y plus 3. There's nothing common in the second pair, so I'm just going to pull out a 1. Sharing the 2y plus 3 in common, that comes out front. What I pulled out is the second term. Now, notice though, these are in y's. We need to go back and substitute back in our substitution. So instead of y, I'm going to have 2x squared plus 3 and 3x squared plus 1. And I've now factored it.